Today, I'm looking at the asteroid startup scene. I'll cover a few of the startups with plans to mine asteroids for metals or volatiles and return them to Earth orbit for sale. Several missions have demonstrated collecting and returning asteroidal material for study on Earth. Both Hayabusa 1 and 2, plus NASA's OSIRIS-REx, were able to collect materials from the surface of an asteroid in deep space. However, these missions were very expensive. OSIRIS-REx, for example, cost over $1.3 billion just to return 121 grams of material. Asteroids can provide fuel, water, and precious metals for use in space, perhaps as feedstock in orbital manufacturing or to fuel space tugs, commercial space stations, or satellites. I'll finish with my thoughts on the current state of the asteroid mining sector. After watching this video, please drop your own thoughts and opinions in the comments section, and we can discuss along with other space news at the weekend livestream. TransAstra has plans to make asteroid mining a reality. Their vision is to build systems that enable humanity to harvest the resources of the asteroids for people to live and work in space. The company plans to attack the problem by developing 4 core capabilities: detect, capture, move, and process. This company has developed flight-ready capture bag technology already. Their capture system was successfully deployed on the International Space Station in October 2025. Using their capture bag, orbital debris can be collected, either for conversion into valuable metals or for deorbiting. This same capture bag technology, once scaled up, can be used for capturing a small asteroid. After detection of a suitable near-Earth asteroid for mining, a mission can be planned for capture and harvesting. Using TransAstra's inexpensive rugged capture bag to envelop the asteroid, then cinch it down, and you now own your very own asteroid. Technically, due to the Outer Space Treaty, you don't own it, but possession is 9/10 of the law. The next step is to use a propulsion system to move the asteroid to its exploitation orbit, probably at a Lagrange point near the Earth. TransAstra are developing their omnivore propulsion system that's powered by harvested asteroidal volatiles to produce thrust. There is not a lot of information about this system, but it appears to use solar thermal propulsion. Basically, a number of solar concentrators will focus the sun's energy onto a small area in a heat exchanger containing asteroid materials, turning the material into plasma that's ejected out of the back of the propulsion system to generate thrust. Omnivore suggests the propulsion system eats anything, so any volatiles in the asteroidal material can be used to generate thrust. Through the use of a solar forge, spin separation, high temperatures, and magnetic fields, a range of metals and materials can be extracted from the asteroid material. In September 2025, TransAstra was awarded $2.5 million contract by NASA to scale its inflatable capture bag system from 1 to 10 meters in diameter. This award was matched by a private investor to accelerate testing and development. The 10-meter version of the capture bag is big enough to envelop small asteroids to enable mining operations in space. In addition to finding and moving near-Earth asteroids, low Earth orbit can be mined. It's estimated that 10,000 tons of material is orbiting the Earth, with more space junk added each year. Joel Sersel, the CEO of TransAstra, said they have been studying LEO space junk for possible exploitation. Up to 50% of the floating debris is aluminium, which is a useful material, as it's lightweight and easy to reforge, giving its melting temperature of 660 degrees Celsius. SpaceForge has already demonstrated a working furnace in space that has reached a temperature of 1000 degrees Celsius. In addition, large trusses could be manufactured, or metal rods for propulsion, and possibly many other parts, components, or volatiles could be extracted given the right equipment and technologies were available. AstroForge, unlike the other space mining startups, has set its focus on prospecting for precious metals within asteroids. Many of Earth's mines are depleted with poor yields after many decades of exploitation, requiring vast sums of money to extract smaller and smaller amounts of precious metals. Asteroids, on the other hand, contain large amounts of these precious metals with high yields. AstroForge estimates 85% yields for precious metals from metal-rich asteroids. A single carefully chosen asteroid could supply Earth's metal needs for 200 years. Keeping a high-tech civilization running requires ever-increasing amounts of industrial, precious, and rare earth elements. A glance at current resource depletion rates shows we're burning through Earth's finite materials at an unsustainable pace. Fortunately, the solar system is teeming with these very resources, offering virtually unlimited supplies. AstroForge estimates 300,000 asteroids rich in metals are in reach. Their first spacecraft, named Broco 1, was a refinery demo in orbit. It launched in 2023 but failed due to technical and operational issues. Next came the Odin mission, launching in 2025. It was 100 kilos in mass and taught the company a lot about operating a spacecraft in deep space. Their next mission, named Deep Space 2, will be the first commercial rendezvous with an asteroid. The mission is expected to launch late in 2026. The company plans to use an ablative refining process that uses laser technology to heat and process asteroid ore directly in space, enabling the extraction of PGMs. This technique is designed for efficiency, aiming to quickly extract valuable metals. Karman Plus. Karman Plus seeks to mine space resources from near-Earth asteroids to provide abundant, sustainable energy and resources in space and for Earth. The company's roadmap includes excavating surface material from a near-Earth asteroid and extracting water for refueling in orbit. This water can be used directly to power spacecraft or decomposed into hydrogen and oxygen, eliminating the need to launch from the Earth's gravity well. This lowers refueling costs for satellites in orbit by up to 10 times compared to Earth-sourced fuel and enables deep space missions that are impossible now. Other space startups have plans or already operate water-based propulsion systems. Examples are Argo Space, Orbital Operations, and Momentus. AstroForge plans to use off-the-shelf components as much as possible to keep costs low, aiming for a mission budget of only $10 million. Mined asteroid water can, in addition to fuel, be used for drinking water or oxygen for life support. Perhaps it could be sold to commercial space stations, orbital manufacturers, or space tug operators. In the long term, heavy industry can be moved off Earth and into low Earth orbit, supported by materials supplied from near-Earth asteroids. The company has all the parts and components ordered for its upcoming spacecraft. Their task in 2026 is to rapidly iterate from prototype to engineering model to the flight model. TransAstra plans to capture small asteroid and place in orbit around Earth. TransAstra is performing a study, funded by investors and customers, to explore the technical feasibility of moving a 100 metric ton asteroid to a stable near-Earth orbit. Joel Sercel, the CEO of TransAstra, explains the company plans to set up a base for research and development of processing and manufacturing in space. New Moon Project. Sercel said there are as many as 250 potential target asteroids with a diameter of up to 20 meters that could be reached with reusable robotic spacecraft over the next decade. By capturing them and transporting them to a new moon processing facility, it provides a single location for large-scale material processing near Earth. One potential place would be the Earth-Sun L2 point, about 1.5 million kilometers from Earth. If fully funded, the mission could rendezvous with an asteroid by as early as 2028 or 2029. TransAstra is working with the University of Central Florida, Purdue, and the Jet Propulsion Laboratory, Caltech, to complete its analysis. Final thoughts. Slowly, the idea of mining asteroids is moving from science fiction and into a commercial market opportunity that we can build for today. For those viewers who like hard science fiction books, I recommend Delta V, a book on asteroid mining in deep space. This book, by the way, is heavily researched and uses as inspiration TransAstra mining equipment in the story. What do you think of the current asteroid mining scene? Is it feasible to capture a near-Earth asteroid and move it to a Lagrange point for processing? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips and slides from this week's videos. It's a live Q&A on this week's space topics where I read out some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.